Assalamualaikum warahmatullahi wabarakatuh. So today our group will present this experiment, which is characteristic curve of semiconductor diodes. So we have 3 members of group, which are me, Amira, Aina and Anisha. The objective of this experiment: first, we need to study the properties of semiconductor. The second one is we need to determine the characteristic curve of semiconductors diode. These are 3 important apparatus that we need to use, which are first, Zener diode, LED diode and 4007 diode. The other apparatus that we use is potentiometer, DC power supply, connecting wires, milliammeter and voltmeter. This is the circuit diagram of this experiment. Basically, we set up our apparatus by using this circuit diagram. So, this is the setup of the apparatus. As you can see, we follow exactly like the circuit diagram. This is the procedure of this experiment. First, the circuit is set up as the figure circuit diagram by using a power generator, a potentiometer, a DC voltmeter, and a diode, which is 4007 diode. Second, current passed through the diode is changed by the means of potentiometer. The current is slowly increased until it reaches the saturation value. Third, the current and corresponding voltage across the forward bias and the reverse bias are read. The voltage and the current are recorded in table 1. 4. The steps 2 and 3 performed above for the LED and Zener diode are repeated.
Hi and Assalamualaikum, I'm Anisha. So I am one of the group members that will represent about the M4 experiment. So I will explain the data that we got. For the first one is LED diode forward bias. As we can see from the table of the data, when the current is at 0 value, the voltage value is 0.765 volt. And what we get, the more the current value increase, the more the volt value increase too. Okay, for the second one is for 4007 diode forward bias. As we can see from the table of the data that we get, when the current is at 0 value, the voltage value is 0.317, and same as before, when the current increase, the voltage also increase. Next is for Zener diode forward bias. As we can see from the table, we can get that when the current is at 0 value, the voltage value is 1.021 volt. And what we can get that the more the current value increase, the more the voltage value increase too. And for the last one is for Zener diode reverse bias. As we can see from the table, when the current is at 0 value, the voltage value is 1.043 volt. And same as before, what we get, when the current increase, the voltage also increase.
This is the graph that we made based on the data that we got from the experiment. So as you can see, for the 4007 diodes graph, the current is directly proportional to the voltage. So for the LED diode graph, what we got is the current is also directly proportional to the voltage. Same goes to Zener diode. What we got while doing the experiment, the data shows the current is directly proportional to the voltage. For this graph is slightly different from the previous graph because it is reverse bias for the Zener diode. So the data that we obtained shows that the current are inversely proportional to the voltage.
In this experiment, we have 3 saturation voltage, which are for diode 4007 in forward bias. In the saturated voltage, VO equal to 0.643 volt. Meanwhile, for LED in forward bias saturated voltage, V0 equal to 1.754 voltage. And the last one is for Zener diode in forward bias, the saturated voltage VO equal to 0.665 volt. When we want to calculate the M, we have the ratio of current in diode for the experiment. So we use the equation like in this picture, in this slide. When taking the V0 and I0, so N equal to EV KT ln 2. So the first one is for for 007 diode in forward bias, we use 0.643 volt for saturated voltage, and we substitute the amp, the gradient that we get from the experiment, and then we substitute into the equation, and n equal to 98.060 plus minus 0.515, and the I equal to 1.54 plus minus 0.008 A that we get from the equation that we substitute the value. Same goes to the for LED diode in forward bias. We substitute the amp gradient, the value, and we substitute until we get 255.97, and the n equal to 255.97 plus minus 0.55, and the I equal to 5.44 minus plus minus 0.00A that we get from the experiment LED diode, that we get the large reading and large the value from the before. And the last one is for Zener diode in forward bias, and we use the saturated voltage 0.5665 volt, and we use the same equation, and we substitute until we get n equal to 11.03. Meanwhile, the n uncertainty is 0.33, and the total ratio of Zener diode in forward bias equal to n equal to 11.03 plus minus 0.33, and we use the uncertainties for y-intercept to get the I equal to 0.6.16 exponent negative 4 plus minus 3.578 for Zener diode in forward bias.
Okay, for the discussion, what we can get from this experiment is that all diode like diode F4007, LED, and Zener diode share the same properties. It involves a p-n junction which operates similarly to a one-way road. This is because the flow current is more easily permitted in one direction than the other. There is a forward bias orientation to the applied voltage. So plus, there are instances where the voltage flow in the other way. Reverse bias is the term used for this, and the p-n junction stop current flow when it is in the reverse bias orientation. From this experiment, we need to find a graph of characteristic, a curve of semiconductor Zener diode, diode 4007, and LED. Okay, for the Zener diode and diode 4007 have nearly identical saturation voltage. For Zener diode, we got 0.643 volt, and diode 4007 we got 0.665 volt, which are close to the forward voltage of silicon semiconductor, which is 0.7 volt. And this silicon has a band gap of around 0.78 volt between the conduction and valence band. For the LED, it has a saturated voltage of 1.754 volt, which is nearly to the theoretical value for a red LED, which is 1.8 volt. Red LED are made of gallium doped with phosphorus and arsenic with a band gap energy of roughly 1.8 volt, and they generate the red light. Due to the lack of data, the reverse bias portion of the IV curve for the Zener diode and diode 4007 cannot be seen. This is because the experiment potentiometer may have reached its maximum, as there isn't a further rise in voltage and also current. From this experiment, we need to find the material constant for Zener diode, diode 4007, and LED, and it estimates by taking the logarithm of the equation. And the gradient of the graph on I against voltage is obtained using the least square approach. For the first one, the material constant for diode 4007, we got 98.60 plus minus 0.15, and for the Zener diode, we got 11.03 plus minus 0.33, and for the red LED, we got 255.97 plus minus 0.55. So the capacity effect of the p-n junction causes the multimeter voltage and current reading to differ. The measurement will change because of the capacitance oscillation in the circuit.
In this experiment that we handling for the experiment, we get error and precaution that almost experiment have error, and how we prevent the experiment for the next time. First of all, the apparatus are not connected properly or loose. This first error, and how we prevent is before starting the experiment, make sure all the apparatus are connected and use the circuit diagram as reference to get the suitable error. And the second one is the apparatus are old or broken. This is common, like we have already experienced before. And how we prevent of the precaution is make sure to check the apparatus or change it to the new one.
For the first question, in your own words, explain how a diode works. Okay, in a p-type semiconductor, the dominant chains carry a whole, whereas in an n-type semiconductor, the majority carries are electrons. When these two types of semiconductor are joined to form a p-n junction, a diode is created. When a current flows through the circuit with the n-type connected to the negative terminal and the p-type connected to the positive terminal, the diode is forward biased. This forward biasing push hole towards the n-type region when they combine with electrons. So this process converts a positive ion in the p-type region into the neutral atom and negative ion in the n-type region into the neutral atom, thereby reducing the rate of the depletion region and lowering the barrier potential. When the diode is reverse biased, electrons in the n-type region are attracted toward the positive terminal, while the hole in the p-type region are attracted to the negative terminal. This attraction widen the depletion region, increasing the opposition to the flow of the current. For the second question, what is the typical voltage value for IR, red, yellow, and green LEDs? So for the IR LEDs, the typical voltage value is 1.5 volt. For the red LEDs, is 1.8 volt, and for the yellow one is 2.0 volt, and the green LED also 2.0 volt. And the last question, from the experiment, what are your conclusions? So what we can get is that the normal diode cannot function in reverse bias, but only the Zener diode can operate in reverse bias. But all the diode can function in forward bias.
Okay, the aim for conclusion in this experiment is for diode for 007 in forward bias, the saturated voltage is 0.643 voltage with 1.54 A for I, and the ratio of the N is 98.60, and for B, for LED in forward bias, we get the saturated voltage 1.754 volt and 5.44 A for current, and the ratio is 255.97. The last one is for Zener diode in forward bias, we get 0.665 volt, and the current is 6.16 exponent -4 A, and N is 11.03.